Hello, welcome to Module 7, which covers questions and answers and clarifications based on the responses we received from you while you were going through the 6 modules. Today we shall be addressing this with Dr. John Rolt and myself, Andrew Otto. And the contents for today's presentation are: 1, a recap of the modules that you covered. 2, questions that you send to us and the answers that we shall provide in this presentation. And 3, there are a number of issues that have come through that require clarifications, and we have called that general clarifications. And lastly, we shall cover some final remarks that are important for your practice going forward. Now we shall recap the 6 modules that you covered as part of the training. The first module was the introduction and overview of the RRN, which looked at what the RRN contained. The second module was on drainage and climate resilience. And here we want you to remember the importance of aspects that affect pavement drainage, such as crown height, invert depth, and the need to use enhanced designs for sections which are at risk of climate change effects. The third module covered the pavement design methods for low volume rural roads. And here we want you to remember that the methods discussed are empirical in nature and should be used precisely as the developers intended and within the valid parameter boundaries used to develop the methods. You should also note that it may be necessary to indigenize or calibrate the methods to your local conditions. The fourth module was quite a big one. It covered material selection, selection of surfacings, economic evaluation, and ancillary factors. And here we want you to remember to use appropriate materials for low volume rural roads. If the materials are not appropriate, minor modification can enhance their properties. We also wish to point out that it is important to steer clear of single surfacings for your road, so it's better to use at least double thin bituminous surfacings. Now, for gravel roads, it is important to get the wearing course right, and that is the primary factor for the design of gravel roads. Now, thicknesses of 150 to 200 millimeters are often adequate for structural purposes. Value for money requires that you carry out some form of economic analysis to either choose or to justify the choice of your pavement structure. So that was also covered. Now, ancillary factors such as borrow pit management and compaction during construction are very important for you to achieve the design that you intended. So please remember that these are important factors that affect your design. Module 5 covered worked examples, and I would like you to remember that in pavement design, you will be required to make engineering judgment about the level of risk you are ready to accept. One of such is the subgrade moisture content at which the design strength of your pavement should be assessed. You as the designer will be required to decide based on the drainage conditions that you expect your pavement to be subjected to in its service life. Module 6 covered solutions to the training exercises that you participated in. A number of you sent in solutions and we gave you individual feedback, and we then provided solutions to the exercises in Module 6. And I would like you to remember that based on the various engineering judgment that each of you made, you can arrive at different answers to the pavement structures that you require for different conditions. We will now look at the questions that some of you sent to us, and we shall provide answers and responses to these questions. The first question was on Module 3, and it states, it was mentioned that less stringent material specifications means the selection of materials could lead to increased risk. Could this statement be further explained? The response to question 1, remember that based on several years of research and evidence, we now have appropriate specifications for low volume roads materials. These specifications have already been made less stringent than those for high volume roads, and they are already considered appropriate for low volume roads. Therefore, if you then make a less stringent selection, it means you are now going beyond the boundaries of what has already been found through research and evidence to be appropriate for low volume roads. In addition to this, I wish you to note that being slightly out of the specification in one parameter will not cause failure. For example, if the plasticity modulus that you end up using is 280 instead of a specification of 270, you are not likely to have any failures. But if your material is near the boundary of specifications for more than one parameter, it is not advisable to deviate in all of those parameters, but you may deviate in one of the parameters, but deviation in all of those parameters may actually lead to failure.
Question number 2 from Module 4, we were discussing the problems of poorly shaped materials, which could be flaky or elongated. The question that we've been asked is it particles break down on crushing or particles breaking down or crushing? The questionnaire says this is not quite clear. We have said that basically we're talking about particle breakdown or crushing. Breakdown is a slightly different reaction than crushing, so they're slightly different, but either one or the other causes problems.
The third question goes, under a risk-based approach to material selection for sealed roads, it was mentioned that 3 classes of traffic and 3 risk levels of rainfall exceeding 500 millimeters per year are used to form 9 risk levels. That is a 3x3 matrix. I think this explanation, backed with a diagram, will easily be understood. Now, our response is, of course, yes, we agree that a diagram would better illustrate the risk-based approach to material selection. However, the publication that deals with this has got very strict copyright regulations and does not permit reproduction of this matrix in any form. However, the publication is free. You can access this publication freely. It's an Ostrods publication done in 2020. The title is shown here in this slide. And you can access this publication from the URL shown at the bottom of this slide. Just follow this URL. you'll be able to download a copy, a PDF copy of this publication, and you can look at this matrix as well as other information contained in the document. It's quite a good document, and I encourage you all to download and have a read and look at this matrix.
There's a question here about the subgrade strength by month and the average that we calculated. The questionnaire spotted that I made an error. I copied from the questionnaire the wrong numbers and calculated the wrong average. So please accept my apologies for that.
Question 5 was a general question. It was not related directly to any of the modules presented. Now, it states, sometimes overloaded vehicles are traveling through our village roads that causes serious or instant damage. We calculate design life in cumulative axles, that is in million equivalent standard axles, based on the standard axle load of 8.2 tons. But sometimes overloaded vehicles contain axles of, say, 20 tons that cause a lot of instant damage. Can I allow a single axle load of 20 or more tons of a truck or vehicle? What is the maximum axle load that I can allow in my road? Our response is that what is described here is actually shear failure as opposed to the general fatigue failure that we designed for by the cumulative axle loads, often abbreviated as MESA. It is usually the combination of high tire pressure, well in excess of 700 kilopascals, and the axle load that causes this kind of failure. Generally, most well-designed and constructed roads can withstand occasional, and I want to stress the word occasional, not frequent, axle loads up to about 15 tons. In many countries, the legal limit for axle loads is about 10 tons. It is not advisable to allow trucks with axles greater than 10 tons on your village roads. If there is a risk of overloading, you should pay particular attention to the particle size distribution of your road base, and you may be required to use coarser materials such as crushed rock to resist shear failure. But of course, crushed rock is quite expensive for low volume rural roads.
The question was, what's the difference between the designs for low volume roads and high volume roads? What is said here in this question is, can we allow heavier vehicles than the 10 tons? And as you've said, occasionally the low volume roads will be able to withstand a few heavier axle loads. But of course, this is a well-known problem. Axle loads are always higher than you have designed for. Operators will overload if they can, and obviously pavement damage is higher than we expect. So this is part of the risks that you have to assess when you're designing the road. If you are in a place where you know a lot of overloading takes place, you would use, as Andrew has said, stronger materials. But there's no way that I know of where it's been possible to actually control the overloading with low volume roads, because they're going through villages and the geometries are not as easy to follow as for high volume roads. The sheer difficulty of negotiating around rural roads often stops operators from using them with large vehicles and very heavy loads. But of course, there will always be cases, as the questionnaire says, where heavier loads are used. And as I say, if you think that's going to happen more often than normal, you would have to use better materials and effectively design the materials for essentially the higher traffic levels. I don't think there's any way around that.
Question 6, another general question, says, is the AFCAP LVR DCP software a free software, or is it available for purchase? Response is that this software is free and it can be downloaded from the RECAP website. And in case you have not been a regular visitor to the website, the URL is shown at the bottom of the slide. And the software has been available, say, I think for more than 4 years now, freely available. So please, you can download a copy from the RECAP website. And I think it comes with all the training instructions as well, the user instructions, so you can follow that. In addition, I wish to let you know that the TRL UK DCP software is free and can be obtained by emailing inquiries@trl.co.uk or aotto@trl.co.uk, and a copy can be sent to you. We shall now present some general clarifications that we wish to put across based on the assessment of the solutions to some of the exercises that some of the participants provided. We observed a number of things that we wish to clarify to further reinforce the points that we wanted to put across in the modules.
This is essentially the same answer that you gave earlier about the specifications for low volume roads. If you recall, we said that with these low volume roads, the material specifications have been based on long-term research studies, and we have found that if you deviate very slightly from one of the specifications, it's not usually a big problem. And in this particular case, the questionnaire has said, can he use material with a DN of 10 when the specification required a DN of 9? And that is a relatively minor change, and as far as we're concerned, that is perfectly acceptable, especially since the strength of the layer above it is actually stronger than the minimum specification. So you've got a little bit of a balance going on there. A small deviation in the lower layer from 9 to 10 would not be significant. The AASHTO method, in the full AASHTO method described in the AASHTO manual, the method of determining the subgrade strength for design is quite complicated, because the representative elastic modulus value for each month of the year are selected and then weighted properly based on the very non-linear relationship between traffic carrying capacity and elastic modulus. It's not very difficult to use because the AASHTO manual has a chart that essentially does it for you, but many people think it's too not complicated, but it's not. You don't need to be quite so inventive, and most people simply adopt a lower percentile representing not the average subgrade strength, but the lower 10 percentile or the lower 20 percentile. It's much easier to do that, and most people understand that. So that's what I would recommend you did. For the DCP-DN and the TRL SADC percentiles, a 50th percentile, in other words, the average, is used for the very low traffic levels below 0.3 million equivalent standard axles. The 25% percentile is used between traffic values of 0.3 and 0.5, and for the highest traffic level in the low volume range, 0.5 to 1 million standard actuals, we would recommend that you use the 10th percentile. So in other words, as you go up in traffic level, you reduce any risk that might be there because of a slight under design. So basically, the 10th percentile for the higher traffic levels and the 50th percentile for the lowest. For road note 31, just to remind you that the moisture content that we're going to use for design is based on the climatic conditions relevant to the road you're in. When you've taken your measurements, the recommended percentile you choose is the 10th percentile for Overseas Road Note 31. We have a question about the major difference in pavement design between low volume roads and high volume roads. The main difference is simply the level of risk that is deemed acceptable. The level of risk depends on the cost of the engineering structure, the consequences of failure, and the perceived importance of that piece of infrastructure. Now that applies to everything, not just roads. And as we know, for example, with our drainage design, for the more expensive structures, we design for the much rarer but stronger storms. The same sort of principle applies to the road structure. So basically, a balance is required. The low volume roads are not as expensive as high volume roads. Therefore, essentially, you can normally accept a slightly higher risk. But in practice, we recommend, or most of the manuals recommend, that for designing for the subgrade, for example, we use a 10th percentile, as I said for the previous question, is higher for low volume roads, but we're still recommending that for the subgrade determination, you use a 10th percentile. The second point there is that for high volume roads, we're looking at the differences. We're using much stronger materials because for high volume roads, as you know, they're the main roads carrying the most traffic, the most freight, and the most heavily loaded vehicles. And so the main difference is that you have to use stronger materials. That's a cost issue. So the high volume roads cost a little bit more because the materials are more expensive. And the other difference between high volume and low volume, we've said before that low volume roads are, because they're not carrying the very heavy traffic, environmental deterioration is probably more important than deterioration caused by traffic. So we emphasize the environmental conditions and the designs that minimize environmental deterioration, because that's more important than the traffic deterioration, provided you're not getting all the overloading, which is always a proviso. So those are the main differences, but obviously at the end of the day, the low volume roads, because there are many more of them, we must make them as least expensive as possible, hence the research that's been done to make use of materials that don't meet the high level specifications for high volume roads.
We have come to the end of the questions and the clarifications that we wanted to share with you. And now for the final remarks that we want to make you aware of, or to emphasize, so that you produce designs which are appropriate and durable for the design life of your road. And the first remark is that you should know your environment, the climatic conditions, and the materials, because the design methods, as you remember, are mostly empirical, and you'll find that some local knowledge of the performance of your materials will go a long way from roads that have been in service. And you may find that these materials may not even agree, the characteristics of these materials may not agree with some of the specifications that have been developed for low volume roads, but they are working well. Or you may find that the materials, much as they're within the specifications for low volume roads, are actually not performing well in your environment. So know your environment, the climatic conditions, and the materials. The second remark is in regards to drainage. And drainage is very important on the performance of low volume roads. And we emphasize the point that you should always endeavor to use sealed shoulders on your roads. That is if you're building sealed roads, but for gravel roads, of course, you cannot seal the shoulders. But you should mind the invert depth for both gravel and sealed roads and the crown height for both gravel and sealed roads. The third point is that you should remember to employ engineering judgment judiciously. That is based on experience that you have observed in your environment. Please remember to apply that in cases that you feel there is some level of uncertainty. Lastly, remember that the pavement design methods discussed here are empirical. Use them within the boundaries of the development of the method, or use trial sections to adapt these methods to your conditions or to extend the boundaries used to develop these methods. We thank you all for participating in the training, and we wish to alert you that several documents regarding not just the rural road node, but other projects can be found on the recap website shown here. Thank you.